Welcome to Secrets of Fast Detection and Recovery from Database Corruptions. So my name is Paul Randall. Some of you may have seen me present here before or read my old storage engine blog. I was in the storage engine team for about 8.5 years at Microsoft. I wrote DBCC CheckDB and Repair for 2005, so I've got a lot of experience with database corruptions and recovering from them. I then managed one of the development teams for the last couple of years of Yukon development. Then for Katmai, I switched over to program management to do a lot more of the what do we build in the product rather than the how do we build it that the devs do. And then in August this year, I finally left Microsoft and joined Kimberly running SQLskills.com and following my passion for presenting, training, and consulting. So my expertise is in disaster recovery, high availability maintenance, and of course, storage engine internals. So why is this important? Why am I talking about this stuff today? A lot of people don't realize they have corruption until it's too late. Either because they don't know that they have to run any kind of consistency checks, or they have a very large database and they've tried to run consistency checks, for instance, and they're not able to for a variety of reasons. And so they don't know what the different options are that they can use to run consistency checks. And so the bottom line is people have corruption. They don't realize they have it until it's too late. And of course, it's more pervasive than it could have been. And so recovering from the more pervasive corruption leads to more downtime than is necessary, more data loss than necessary. So people think it's the platform that it's wrong rather than the database administrators not having the knowledge that they need to know what to do. And so overall, it leads to a lower perception of SQL Server compared to other RDBMSs. So what I want to talk to you about today is three things. First of all, how to go about detecting corruption in SQL Server 2005, how to go about recovering from corruption once you have it, and it's almost inevitable that in any DBA's career, you're going to face corruption at some point. And then finally, some best practices and some examples to learn from. I've taken 4 examples, 4 of the worst corruptions that I've ever seen at customer sites from when I was working with product support. And I'm not going to tell you who they were from, but I'm going to walk through what actually happened and tell you some of the mistakes that they made and what can be learned from them. So I'm happy for you to ask questions at any point. There's these kind of microphones at either side if you could try and use those because we're recording the session. And I guess that's it, let's go. So detecting corruption. The first thing you have to know about is what you're actually looking for. The thing you're most likely going to see is an I/O error, okay? Either in the error log or a user is going to call you up and say, I was running this query and I've got this funky error come back, what does it mean? So in 2005, there's 3 different kinds of I/O errors you can see. First one is an 823 error. There's actually a mistake on the slide. It should be 823, 824, and 825. So an 823 error is what you would have seen in SQL Server 2000. And an 823 error is, in 2005, is the operating system has been asked to read a page, and it can't read the page. Okay, so it's tried to ask a device to read a particular page, and the device, the I/O subsystem, has come back and said, no, I just cannot read that, okay? We call that a hard error, okay? An 824, which is the middle one, is a soft I/O error. That's where the operating system managed to read the page, but SQL Server itself has determined that there's a problem, okay? So as far as the OS is concerned, the file's fine, but SQL Server has determined that something is corrupt in that particular page. Maybe it's a torn page error or a page checksum failure, for instance, and I'm going to talk a little bit about more of these in the next slide. And then the next one you might see, and you'll only see this in the error log, is what's called a read-retry error. And that's where we had to try multiple times to read a page, and it either worked or failed, but you'll get this error message in the error log. And again, I'm going to go into that in a couple of slides. So you might notice if you're already on 2005, show of hands, how many people are only on 2000? Okay, everyone else has got a mixture or they're on purely 2005, okay? In 2005, if you get an I/O error, you get a much nicer error message than you did in 2000. In 2000, it would say something like, we detected this problem at this offset. Please see your system administrator. And you're thinking, well, I am the system administrator. Okay, what am I supposed to do, right? So in 2005, we changed a bunch of these really critical error messages, and this is actually why we took 5 years to bring out SQL Server 2005, as we were rewriting error messages. We changed them, so you read through this, and it tells you actually what happened, and then it says, look in the SQL Server error log or the system event log for more information. This is a severe error condition that threatens database integrity, must be corrected immediately. Complete a full database consistency check. This can be caused by many factors. For more information, see books online. So instead of just saying something's wrong, it says there's something wrong, where it happened, and it tells you where to go to get some more information. Okay, so it gives you a little bit more prescriptive guidance. And you'll see this in some more of the other error messages, the kind of critical error messages in 2005, where we rewrote some of them to give I say we, Microsoft, but I was still at Microsoft at that time. We rewrote some of them to give you a little bit more guidance on what to go and do, rather than just, here's an error, figure it out for yourself. Okay? So the first thing you should probably do before installing SQL Server, or in fact, if you have SQL Server and you're seeing errors, you can run this too. Before installing SQL Server on a new system, run this tool, SQL IO Sim. It's a completely free tool that we put out in October last year. And what it does is it simulates an IO workload of a typical SQL Server, but it's going to simulate it in a much, much more stressful way than your SQL Server is going to do. It's basically going to push your IO subsystem to the limits. And the reason for doing this is because you want to expose any issues in your IO subsystem before you start SQL Server running on it. And of course, the only way you can do this is to use some kind of stress tool. I found in my experience that the disk stress tools that the actual hardware manufacturers provide don't do anywhere near as good a job as something that actually simulates a real application workload that this tool will do. So you can, apart from just simulating an application workload, you can simulate specific things such as a DBCC workload, a read ahead, some bulk load, something like that. The thing to consider here is, although you're running this against the hardware, it's not just the hardware that you're testing. The I/O subsystem underneath SQL Server is not just hardware, it's also software. When an I/O leaves SQL Server, it goes into the operating system. Then it might go through any filter drivers, down into device drivers, down into RAID controller software, and down into any software that might even run on any drives. And any one of these bits of software could be millions of lines of code, just like SQL Server is. So when you're running this simulator, you're not just testing the hardware, you're testing the entire I/O subsystem, including all the software. Okay? So there's a blog post there, and some of these slides have links to blog posts that I've done on my blog, where I go into an awful lot more detail about a specific subject. And this one here, for instance, it has links to where you can get the tool from. It has links to a number of different websites that explain how to interpret the results, and also some KB articles. Okay? So anywhere you see a link to a blog post, that says there's a bunch more information, you can go and have a look. Page checksums. So in SQL Server 2000, in fact, and in 2005, but the main thing in SQL Server 2000 was torn page detection. So what torn page detection would do is it would allow you to detect when, say, a power failure happens and a drive is in the middle of writing out a page and it doesn't have enough battery backup to continue writing the page out. So what you have on disk is you have half of the old page and half of the new page. So we call that a torn write, okay, because the page is torn in half. So torn page detection can detect that. But what it can't detect is when there's, say, a single bit flip, okay, on a page, somewhere randomly on the page. So in 2000, we could get into situations where product support and the development team could tell by the corruption pattern on a page that it was something in the hardware rather than SQL Server that had caused corruption. But there was no actual proof. So we get into these situations where at a customer site, the hardware vendor would be pointing at us and we'd be pointing back at the hardware vendor. And there's no proof that it's not SQL Server. So in 2005, we put this thing in called page checksums. What a page checksum is the very, very last thing that happens to a page as long as page checksums are turned on. When it leaves the buffer pool, we calculate a checksum over the entire page, stamp it on the page. When the page is subsequently read back into the buffer pool, if it has a page checksum on, the checksum is recalculated. If the checksum is different from the one stamped on the page, that's proof that something in the I/O subsystem underneath SQL Server has changed the page in some way. So that provides what I call the smoking gun that something in the I/O subsystem is the problem and not SQL Server. Now, apart from giving us the ability to say it's not us, okay, right, it also gives you guys the ability to very quickly find corruption issues. Okay, because it detects far more problems than torn page detection does. A couple of caveats to this. It's on by default for all new databases you create on SQL Server 2005. It is not on by default when you upgrade a database. If you upgrade from 7.0 or 2000 to 2005, you have to go and switch this option on. Okay? When you switch it on, nothing happens. Okay? You just flip to database setting. A page is not protected by a page checksum until it's read into the buffer pool, changed in some way, and then written back out to disk. Only then will it have a page checksum on. And the real bummer is that there's no tool that we provided to go and write page checksums on every page. So that means if you switch page checksums on to an updated database, you've got to go and either force an in-place update of all the pages, or for instance, do an index rebuild of all the pages. Okay? And that'll generate the page checksums. So if a checksum failure happens, you'll see an 824 error, as I just explained what the IO errors were. And that'll be in the error log, it'll also be in the event log, and the user will see a disconnected connection when that happens. There'll also be an entry put into the suspect pages table in MSDB. And you can use that suspect pages table, which lists all the pages that have had IO problems, to drive, for instance, single page restores. If you're on Enterprise Edition, for instance, you could do online page restores to fix those. The overhead that we measured during development of Yukon for having page checksums enabled for a heavily loaded 32-way system running an OLTP workload was around 1 to 2% CPU. Hopefully most people don't have boxes that are pegged in terms of CPU, and so the extra 1 to 2% CPU overhead of having this turned on is a great trade-off to the, being able to fast detection of corruptions. Oh, one other thing. It's not an error-correcting system. All it does is detect errors. To generate an error-correcting checksum would take an awful lot more CPU power, so we didn't want to do that. Okay? So page checksums are checked when the page is read in normally, as long as there's a checksum on the page. When a page is read by CheckDB, because CheckDB by its very nature has to read every allocated page in the database, and so these page reads are done using the buffer pool, and it's the buffer pool that does the page checksum testing. So running a CheckDB will read all the pages and test all your checksums. That's why it's a good idea to run regular CheckDBs if you have page checksums turned on. The page checksums will also be checked when you do a backup with checksum. Backup with checksum is a new feature in 2005 that not only will test page checksums and fail the backup if a page has a checksum failure, but also generates a checksum over the entire backup stream to give you some extra kind of validity checking of the backup itself. And it will also be checked if you do a verify only, for instance, of a backup that was taken with a checksum. When it reads through the entire backup stream, it'll validate the checksums on the pages in the backup. And also if you do a restore with checksum, it'll recheck the page checksums as it pulls the pages out of the backup and writes them onto disk. Okay? So the two gotchas, the second one I've already told you about, and the first one is it's not available on TempDB. Okay, so all other databases apart from TempDB can be checked for page checksums.
Hey Paul, you said it wasn't corrective, but what about 2008?
No, in 2008 there's no that's an interesting one. So what Kimberly was just saying was in 2008 there's a very cool feature that was put in for database mirroring. If you have a database that's mirrored and the principal has a page checksum failure, the system will automatically go over to the mirror because the mirror is an exact copy of the principal. And if the page is not corrupt in the mirror, it'll suck it back over to the principal and correct the problem. Okay? Now it's a band-aid, okay, because you've still got an issue on your I/O subsystem, but it means you don't take any downtime. You've still got to go and figure out what was wrong and take corrective action, but it's fixed it automatically. And that also works the other way. If something goes wrong with the mirror, then it'll go over to the principal and pull the page over and fix the mirror. So it doesn't break mirroring. Okay, thank you. So read retry I mentioned earlier on. This is actually a feature that I don't agree with. What it is in 2005, if we try to read a page and we get a page checksum failure, we don't instantly stop. We'll try 3 more times. And if on, say, the 4th time it works, then the user doesn't know any problems. What you'll get, though, is in the error log, you'll get an 825 error saying what's up there. Okay? We had to use read retry to read a page. Okay? So it doesn't fail fast if there's an I/O subsystem problem. If after the 3rd retry the I/O still doesn't succeed, then the user will get an 823 or an 824 error. Okay? So there's 4 tries to read every page. If you ever see one of these, and I advise you to put an alert on 825 errors, in fact on any Sev24 error, if you ever see one of these, it means something is going wrong with your I/O subsystem. You've now got transient problems. Okay? So if you ever see one of these, go and start digging in and figure out what's going on. Okay?
Yeah, just to add to that though, Paul just mentioned that you should have alerts on severity 24. I would even argue that severity 19 through 25 are severe enough errors that you kind of want to know that something's going on, and the sooner you know that that problem is occurring, the easier it is to solve it. So by setting alerts that are severity-based, you'll be aware of those problems even earlier. So 823, 824, 825 is pretty isolated to just hardware. You probably want to know about any error in the sub 19 and higher range, and it's very easy to create alerts on those severity errors.
Okay. Any questions so far on what we've been saying? Yes? Okay, the question is, if you upgrade a database from 7.0 2000 to 2005, will it turn checksums on? The answer is no. It's only for databases that are created on 2005 or higher that have page checksums on automatically. If you upgrade a database, you have to specifically turn it on. It's alter database, database name, set protection to set page protection,
Page verify.
set page verify option, checksum. Okay. If you look on my blog as well, if you look under the category IO subsystems, there's a whole section on page checksums, IO errors, read retry, and how to go about switching it on. And also examples of, in fact, this is good. There's a couple of example databases that I've posted on my blog, one for 2000, one for 2005, that have engineered checksum failures in them, so that you can restore it, you can run queries, you can try backups, and you can actually see how the system is going to behave with one of these checksum failures in a database.
And Paul, to reiterate this upgrade issue, when you guys bring a database from 7.0 or 2000, when you bring it over to 2005, Paul mentioned that even if you turn on page checksums, they're not there until a page gets written to. And just as a heads up, Paul wanted to write a tool, and unfortunately, the internal commands he would have to use to generate the right details for a page checksum without modifying a page would generate a lot of error log information. However,
hopefully in SP3, Ryan Stonecypher, the guy that took over CheckDB for me, is going to change this internal command, and I'll be able to put a tool out that will actually go through and touch all the pages in a database without having to do a rebuild or something like that. So, but I don't know when SP3 is coming out, so hopefully sometime within the next year we'll have that tool. But still nothing from the SQL team on doing that. In fact, in SQL Server 2008, there's still no tool to go through and touch all the different pages. Okay. So, I mentioned this is an FYI, okay? I don't want you to go and turn this stuff on. If you're having problems figuring out what's going on with page corruptions, then there are a couple of trace flags, and they've been documented in white papers that the SQL team's put out that you can turn on that might help. There's one for data pages, and there's one for log. The one for data pages is trace flag 806, and what it does is, apart from checking page checksums, it will also do a small page audit of every page. It's the same kind of page auditing that DBCC does, CheckDB does, if you run with the physical only option. It'll do some validation of the page header, and then it'll look at every row, do a kind of gross validation of the row structure, make sure the rows are ordered correctly, and so on. The problem with that is, it takes an awful lot of CPU overhead to do that. So it's not something that I advise you to go and turn on production systems just because it might help you find out problems more easily. You only want to turn this on if you're actually having issues that you can't track down, and you're probably going to be already working with PSS. But I wanted to make sure that you guys knew about these different trace flags. And again, there's another one for logging, for log records, and that's trace flag 3422. And it does the same style of auditing as trace flag 806 does. But again, don't go turn these on, I just want to make sure you knew about them, okay? So if you're interested in how the IO subsystem works and a lot more information about the different kinds of problems that can happen to an IO subsystem, there's two white papers that were written by a guy called Bob Dorr, who's a senior escalation engineer in product support, and I helped review these. There's one for 2000, one for 2005, which goes into the entire issue, every single issue about how an IO subsystem works inside SQL Server, because it's slightly different in 2000 and 2005, and what kind of problems will manifest themselves and how they'll manifest themselves. So very, very good, very, very technical white papers, not something you probably want to read at bedtime, but if you do want to see more information, I highly recommend you read these. Okay? And again, there's links to these off our white papers page, I believe, on SQLskills.com.
Yeah, we put together on SQL Skills a white papers page just because we couldn't remember, is it on Microsoft.com, TechNet, MSDN? So it's just on SQL Skills whitepapers.asp, and it's got about 40 different white papers, some of which are 100, 125 pages long. I mean, they're like chapters of books, really detailed on a variety of different things. And we just tried to consolidate them, and they just point to the Microsoft.com and so forth links. Okay.
So CheckDB. CheckDB is going to be the best way to try and find corruption in your database. Turn page checksums on, and then run a CheckDB. Okay? of course, make sure the checksums are there on all the pages, and then run a CheckDB every so often. Because remember, CheckDB is the only thing that's going to read every allocated page in the database. Now you might say, well, a backup does that too. But a backup will, if you're doing a backup with checksum, it'll stop if it finds a single checksum failure and say this database is corrupt and it's not going to back it up unless you choose to force it. Okay? But CheckDB is the only thing in the system that can kind of eat checksum and I/O failures. You'll never see an 823 or an 824 error from CheckDB. What you'll see is a description of what's actually wrong with the page and what the ramifications are of that page not being able to be read. Okay? Because if it comes across a page, for instance, that has a hard I/O error, it won't process that page. Now, if that page is in the middle of a B tree, then all the linkages in the B tree are effectively going to be broken as far as CheckDB is concerned, because it doesn't see all the right bits of information. So you'll see all the information about what's broken because that page can't be checked. So you can choose between running everything and running with physical only. Now, with physical only is an awful lot faster than running everything, because running everything means all the higher level logical checks that take an awful lot of CPU power to run. Whereas with physical only, all it does is it reads the page, which forces the page checksum to be checked, plus it does a page audit. Okay? So it's a lot faster. It's more I/O bound than CPU bound. Okay? So going from 6.5 to 7.0 and 7.0 to 2000, 2005, CheckDB is now online by default. Okay? It's a misconception that it still causes blocking. It doesn't from 2000 onwards. There's different algorithms in 2000, 2005 to make it run online. And if you're more interested in that, then I'm going to be doing a chalk talk on Thursday morning on how CheckDB works, the internals of DBCC. So I'll come along to that. In 2005, there were some new features that I put into CheckDB. First one is progress reporting. You can now tell using the sys.dm exec requests DMV in the %complete column how far through a particular phase of CheckDB it is. It'll tell you a list of different phases and then how far through each one it is, so you can get an idea of whether it's got bogged down in one particular section or not. Data purity checks. So in editions before 2005, it was possible for corrupt data to be input into the server through various mechanisms. For instance, RPC, you could import invalid float data into the server. Now in 2005, all the import mechanisms have data type checks on, so that's no longer possible. But in previous versions, you could import this data, so it could be the case that you've got invalid values. And I've spoken to at least one person today that after they upgraded to 2005, they ran this particular check called data purity and found a bunch of the databases had invalid float data from previous versions. So what data purity does is for any column value, for any column type that can have a particular range boundary on, so for instance float or say date time, it does a check that the value is within the defined range for that particular type. So for instance, in a date time column, there's a section minutes after midnight. Okay? Now obviously minutes after midnight can't be more than 1,440, because that means it would be into the next day. So that's one of the checks that happens when there's a date time column. If there's any issues with any column type, you'll get an error message. It'll be a 2570 error message, and it'll tell you where the particular problem is, and you'll have to go and update it manually. Repair can't fix those because it can't determine what the correct value should be. Okay? When you upgrade a database, you have to manually go and say, please run data purity checks. It doesn't do it by default. You have to manually do it. Once you've done it, and it's found that there are no problems, it will flip a bit in the database metadata that says this database is now pure. And from that point on, the data purity checks will be run by default. Okay, you don't need to go and specify data purity. If you create a database on 2005, because all these holes in the import mechanisms have been fixed, any database that's created on 2005 is automatically deemed to be pure. So these checks are run automatically. Okay? But if you do upgrade a database, I recommend that you do run this CheckDB with data purity at least once to see whether there's any invalid values. Because an invalid value could cause havoc with a query or a query plan, for instance. Okay? Index views. So an index view is a clustered index in its own right. So as far as CheckDB is concerned, it's just another table. Well, it's a little bit more than that, because an index view is persisting the results of a query. One of the things that CheckDB has never done in the past until 2005 is actually check the contents of an index view match the view definition. So in 2005, what CheckDB will do is it will create another index view, because the index view definition is stored in metadata. So it creates another index view in TempDB, and then it does two left anti-semi joins between the existing view and the new view to see whether there's any missing rows or any extra rows. And if there are, then the repair can fix that by rebuilding the view. We store now the last known good run of CheckDB in the database metadata. So when a database is started up, it will report the last time that CheckDB was cleanly run. And also product support can use that as well when they're trying to debug corruption issues. Excuse me. And no more false failures. So the mechanism that CheckDB used for running online in 2000, which I'll go into more details about in the short talk, basically used log analysis. And there are a couple of pathological cases where there wasn't enough information logged, so I had to make an educated guess as to what happened. And within those pathological cases, there's a couple of cases where there's just not enough information and the guess is sometimes wrong. So you might see, and there's been cases of this, where you might see a failure reported where there isn't one. You'll never see a case where we miss a failure, but in 2000 you might see a failure reported where there isn't one. So sometimes people say, if you get a problem in CheckDB in 2000, run it again just to make sure, or run it again with Tablock just to make sure. In 2005, that's no longer the case. We switched the mechanism to use a database snapshot instead of log analysis, and so you'll never see these false failures.
And again, if you ran CheckDB and had a failure, you only have to run CheckTable on the tables that generated the error, so you don't have to do the full CheckDB again.
Yeah. So CheckDB is all very well, but then you get into the question of, when should you run it? How long is it going to take? And so on. How do you interpret the output? And I'll get into that into the next section. Oh, I'll get into it in this section, in fact. There we go. So, tricks and tips. CheckDB output, if you've ever seen CheckDB output, it's not exactly user-friendly. Okay?
Yeah, who wrote that, Paul?
Yeah, I know. If you have one error from CheckDB, you can kind of work out what's going on, because a lot of the error messages are now documented in online books online. If you have 10 or 20 or 50, it's really hard to figure out what exactly the root cause of the problems are. Okay? So if you have a lot of errors, I don't even recommend that you try and figure out exactly what's wrong, but there's a couple of tips and tricks you can use to figure out what you can do about it. So the first one is, if CheckDB says you only have to do a repair rebuild to fix the problems, that means that it's only non-clustered indexes that are damaged. So apart from doing whatever root cause analysis and so on to figure out why the problem occurred, you don't need to run repair allow data loss. Okay? You don't even need to restore from a backup. You could just rebuild the indexes. Okay? Except, there are a couple of bugs where sometimes it will report repair allow data loss, even if it's non-clustered indexes. So if it's not repair rebuild and it's repair allow data loss, you could still check whether it's just non-clustered indexes. Every error message that it reports has an object ID and an index ID and some other information. Every non-clustered index has an index ID of 2 or more. So if you look through the error messages and all the index IDs are 2 or more, that means it's only non-clustered indexes that are damaged. So again, you could just rebuild those rather than having to run a full restore or running repair allow data loss, for instance. Look at the list of tables that are affected. Again, I said every error has an object ID and an index ID. Say there may be like 100 errors, but they could all be one table. If you've set up your system to be able to isolate damage, if you've got a table on every single table's on a particular file group, for instance, then what you may be able to do is just take that one file group offline in 2005 and then restore it later, or restore it individually rather than having to do a full database restore. Okay? So you can see where I'm kind of going here. It's not so much this error means this and this error means that. It's more, have a look at the whole list of errors and see whether you can draw any conclusions from everything that's happening, right? Apart from looking at the list of tables, look at the list of pages. Are there only 2 or 3 different pages that are affected? In that case, you may be able to use single page restores to restore those, rather than having to do a full database restore. Is it a problem that CheckDB can't fix? CheckDB can't fix everything. There are a few errors that CheckDB cannot repair. So if it stopped early and said system tables are corrupt, okay? In 2000, you might see an error saying, could not read and latch page blah in sysindexes, and it just stops, okay? In 2005, those errors have been kind of updated to be a little bit more user-friendly. But again, if it just stops and complains about one of the system tables, game over. CheckDB can't repair that, so you're going to have to restore from a backup. If you don't have a backup, then you're looking at exporting as much information out into a new database as possible. Okay? Did CheckDB stop and give you an error about any metadata corruption? So it's not a system table that's corrupt, but it's something inside the system tables that doesn't jive properly. If that's the case, again, CheckDB can't fix that. Okay? Any error in metadata, the repair would be to say delete the page in the metadata table. Now the metadata tables are holding the critical information that for hundreds of different tables on each page. If you deleted one of these pages, you'd be effectively deleting hundreds of tables. And to most people, that's not a palatable way of repairing the system. Okay? So it's better to say CheckDB can't repair that and force people to go to a backup or to export out to another database. The one that I've seen that does catch people out sometimes when they don't have a backup is PFS page header corruption. So there's an allocation bitmap called a PFS page. And that's one of the things that CheckDB bases its checking on. There's the system tables and there's the PFS pages. If a PFS page is corrupt in its header, then that can't be repaired, because the only way to repair that would be to either force all pages to be allocated in that particular interval of the database, or force them all to be deallocated, and then run CheckDB, run repair, and kind of work out which ones could be allocated and which ones couldn't. There's basically no deterministic way to fix that particular problem. So given that there's no deterministic way to fix it, we can't put it into the product. Okay? Repairs have to work, and they have to work solidly in all cases. So again, that's another case that CheckDB can't repair. If that's the case, you have to restore from a backup. Okay? If you try to export data out when you've got one of these PFS header problems, there's a 64 megabyte chunk of your database you can't read, which could be for lots of different tables. So you are going to lose data when you do the export. Okay? So all of these things that I'm saying where CheckDB can't fix problems, and I'm saying, well, you could try and export stuff out, or you could use your backups. I'd really like you to use your backups, okay? So this is all saying, take backups, take backups, take backups, okay?
But what if you don't have a backup?
We'll get to that, yeah. So this isn't really interpreting the output, but one of the things that you should always know is how long does CheckDB take to run in your database? A number of different reasons for that. Firstly, if you do have a kind of corruption, then you're probably going to want to run CheckDB. And it could be that the extra I/O and CPU load of CheckDB doesn't allow you to continue normal workload processing while CheckDB is running, in which case you've got to make a call about whether to shut down your workload or not. If you don't know how long CheckDB is going to take, you don't know how long you're going to have to shut down your workload. Okay? The other thing is, CheckDB, if it finds a corruption, can sometimes run a lot longer, depending on what the corruption is. An example of this is an algorithm we have that checks the validity of non-clustered indexes. Every row in a non-clustered index has to map to exactly one row in the base table. Every base table row has to map to exactly one row in each of its non-clustered indexes. There's a very efficient algorithm to check whether that's the case. The problem is it's a very lossy algorithm. It'll detect that there is a problem, but not where the problem is. So if we detect that there is a problem, we have to go and rescan all the data again in a different algorithm to figure out where the problem is. This makes sense because, given the millions of times a day that CheckDB is run, the vast majority of the time there isn't an issue. So it's better to err on the side of having it run faster, and then on the error case, take a little bit longer. Problem is, in the error case, it can take a lot longer. I saw one customer where the regular CheckDB took 6 hours. When it found a couple of non-clustered index problems, it took 37 hours. Okay? The key here is that if you know how long CheckDB usually takes to run, say 6 hours, if it starts to run a lot longer, then the alarm bells can go off. Okay? Something's not right here. And up until SP2, there was no way to know whether one of these deep algorithms had been triggered. But in SP2, there was an error message put in 5268 that's now output to the error log whenever CheckDB's found some issues, and it's going to go and do what's called a deep dive to figure out where the actual issue is. Okay? So if you're on SP2, then I recommend that you put an alert on 5268 in the error log. Okay? So you get a little bit more early warning that CheckDB's found a problem. And if you do get a 5268 error, I've never seen it not happen where there isn't corruption. Okay? Double negative logic there. If you see a 5268, there's corruption. Okay?
And don't kill CheckDB just because it's taking too long. Because you want to know what the error is so that you can know what the disaster is to recover from. And if you kill it, you're just going to end up having to run it again. So, I mean, it's something that we see a lot where people will just react and say, oh, this is taking too long, so they'll kill it, thinking it's just an anomaly, there wasn't any corruptions, but it's because it hasn't told you what your corruption is yet, and it's inevitable. So.
Yeah. So that's how to detect corruptions. Any questions on that before we move on to how to recover when you do have a corruption? And I say when, because you probably will, not if. Yes?
Pessimist.
Sorry, I can't hear you. Is your backup always correct? Is that the question? Okay, the question is, you have a database, the IO subsystem corrupts something, you take a backup subsequent to the corruption. Isn't that corruption in the backup? The answer is yes, absolutely. So the key there is figuring out, and we're going to get into this, which is how often should you run CheckDB, okay? There's no easy answer to how to protect against that. I mean, you could have a high availability system where you have database mirroring, for instance, where if a bit flip happened on the IO subsystem, you'd have to be extremely unlucky for the consequences of that corruption to also be transmitted over to your mirror database. Okay, because mirroring is a log shipping solution. Okay, the only way that corruption could get over to the mirror is if the bit flip didn't have what happened on a page that there wasn't a page checksum on it. Okay, and something read a column value where the bit flip was in, and then used that column value to create another value, which was then persisted in another page, and then the log records for that calculation and write were then shipped over to the mirror. That's called a kind of second order corruption. But the actual primary corruption of the bit being flipped wouldn't be copied over, okay? Unless you took a subsequent backup and used that to set up your mirror. You see what I mean? But yeah, any corruption that's in the database, when you take a backup, it'll also contain the corruption. So the key there is, if you take a backup, say once every 6 months, then you're probably going to have some problems. What are you going to say?
Well, I was just going to say that you said database mirroring is a log shipping solution,
well,
and
I just
yeah, but I just want to clarify that it's not based on log shipping. It's a totally different algorithm. That's all. But it is a form of shipping the log. Yeah.
Any other questions? Yes. Question is it possible that CheckDB will pick up an error that's just in the cache? And the answer is yes. And it's a very good question. On Enterprise Edition, there's an extra twist to page checksums. There's an algorithm inside the buffer pool called the lazy writer, which is what's responsible for pushing pages out of the buffer pool to disk in a kind of least recently used queue fashion. And as part of that lazy writer thread, on Enterprise Edition, if there are pages in the buffer pool that have page checksums on them, and they haven't yet been changed, so they're clean pages, then the lazy writer will check the page checksums on those pages to see if there's any kind of in-memory corruption. Okay? And on many customer sites, we've actually found that there are rogue processors being able to write into the SQL Server's buffer pool memory and actually corrupt pages, so that's actually found problems. Great question, thank you. There's a question down here somewhere. No? Okay. So how to recover when you do have a corruption? First of all, don't do this, okay? Don't panic. If you panic, and again, we've seen this on many customer sites, if you panic, you're not going to make good choices, okay? You might do a kind of knee-jerk reaction and immediately run repair, okay? Or immediately rebuild the log, which is not the right thing to do, okay?
Oh, or let me add one into this. You might immediately go to your backups and restore them, which sounds like a good reaction. And this is something that they changed between 2000 and 2005. But in 2000, if you haven't backed up the tail of the log, they will allow you to overwrite a database that has a log that's not been backed up. So if your last log was, a minute, 2 minutes, you're kind of lucky there. But if somebody has a log that's an hour ago and they get really excited and say, okay, I know I need to, not that you'd be excited about restore, but I mean, they get kind of excited, they panic.
You get excited about
I do get excited by restore. But so they start their restore sequence, restore their backups, and then they get to their last log and they realize that they never backed up the log. You actually can't do that in 2005. In 2005, if you try to restore on top of a database who has a tail of the log that has not been backed up, you'll actually generate an error. So that's actually a little protection mechanism that they went into in 2005 because they saw a lot of this, people overwriting. But it's, I think it's not just panic. To me, it's something that's not planned. If you haven't planned your restore or your backup strategy, if you haven't tested it, documented it, it's not just panic, it's just, you're not following a plan. And that plan can get very messy as you start to get nervous and you have more downtime and your boss is screaming. And
so we both scuba dive, and there's a saying for scuba divers which is plan your dive and dive your plan. Okay, don't deviate from your plan because then something horrible could happen. Same kind of thing for disaster recovery, okay? Come up with a plan for disaster recovery, and when the disaster actually happens, keep your head and follow your disaster recovery plan. because that's what you spent time working out in advance. Don't panic and just jump, okay? Okay. So first off, don't panic, okay?
Yeah.
Or don't do any of these. I see these all the time in the user groups, okay, in forums. Don't restart SQL Server. If you've got a corrupt database, it's not going to help you. If you have a corrupt log, it's not going to help you. Basically, it's not going to help you, okay? Don't restart SQL Server. Don't run one of the last resorts. Don't immediately rebuild your log or run repair, okay? Think through all the different options before you take one of these drastic steps. And I'm going to go into more information about these in a couple of slides. The chances are that if you run one of these, you are going to cause more damage, okay? Don't ever detach a suspect database. If you detach a suspect database, you will not be able to reattach it, okay? A suspect database means that recovery could not complete. It's not that it couldn't start, that's called a recovery pending database. A suspect database means recovery started and something happened and it couldn't finish recovery. It had a corruption and it couldn't finish. If you detach the database and then reattach it again, it's going to try and run recovery and it's going to fail and it will fail to attach, okay? If you have one of these databases, the only way to get it to attach is there's a hack method that you can use, creating a similar kind of database, shutting the server down, swapping in the files, and then starting it up. It's not pretty. Okay, so don't ever detach a suspect database. And again, don't depart from your plan. You've spent a lot of time working this out, hopefully, about what to do with a disaster when a disaster happens, having people test it and so on. Make sure you stick to the plan. So one of the things you may be able to do is have a choice between running a restore or a repair. And it depends on a bunch of different things. So it's basically a trade-off between taking data loss and the amount of downtime, okay? As with all these things, I can't say you should always do this. There's no basic easy answer, okay? I could give an answer for a particular situation, but then that might not work for someone else's situation, okay? It all depends on your particular situation. So although I can't give you an answer, I can give you a bunch of questions that you can answer for yourself that can help you make an informed decision. So before you start, you've got to have some bits of information. First off, do you have backups and are they valid? Okay. How long does it take to restore backups in different granularities? How long does it take to restore a full backup? What about file group backups if you do them? What about any differential backups? What about log backups? Have you tried doing backups, tried restoring backups to specific points in time? Do you know how long that takes? Can you do single page restores? How long does that take, depending on how much log has to be rolled forward? What are your downtime and data loss agreements with your management? Can you have any data loss at all, or is it zero data loss? Can you have any downtime at all, or is it zero downtime? And then what's corrupt, what's damaged? Is it a data file, or is it a log file, for instance? So once you have these bits of information, then you can start working through some questions and some decision points that can lead you to an answer of restore versus repair. First off is, do you even need to do anything? As I explained, you can look at the output from CheckDB, and it might be just non-clustered indexes that are damaged. In which case, you don't necessarily have to take downtime. If you're on Enterprise Edition, you can do an online index rebuild of the non-clustered indexes. Okay? And then go and work out what happened to make sure it doesn't happen again, but you can avoid downtime. Do you actually have a database to repair? Have you lost the entire database files themselves? In which case, I hope you have a backup, okay? Because backup is your only option. You can't run repair on a database that doesn't exist. Is the log file damaged? If the log file is damaged, then hopefully you've got a backup, because if you don't have a backup, you can't run repair unless you're in emergency mode. And I'm going to go through all these different options in a couple of slides. Do you have a valid backup? If you don't have a valid backup, then repair is your only option. Now, if you've lost your database files, but you have a damaged backup, you can force the damaged backup to restore. There's an option called continue after error, which says, I know that this database, this backup is damaged, but I really need it back, so just restore it anyway. Now, you'll probably find that there's corruption in the database, but at least you've got a database. You can run repair on it, okay? There's also an option for a continue after error on backups, okay? You might find that if you don't have a backup, but you've got a corrupt database, now you're going to have to repair it. But prudence says you should take a backup before you do anything with this corrupt database. Just in case something goes horribly wrong, you can at least restore back to your original corrupt state. If the database is so damaged that backup refuses to take the backup, you can force the backup, okay, with continue after error. I know this database is damaged, but I really need to take this backup, so please just back it up. So carrying on with these decision points. Is the damaged data in a non-critical file group? It could be a read-only partition of a partition table, and you don't use that partition very much. So you could just take the file group offline, and you could restore it later. It could be a non-critical table that you've isolated into a particular file group, or even a critical table, but a table you've isolated into a particular file group, just so that you can do kind of piecemeal restore and have partial database availability while you're doing this restore of a single file group. Okay? What's your database, your data loss SLA? If you're not allowed to lose any data, then you can't run repair. So you better have a backup. Okay? Then figuring out what's the smallest subset of the database that you actually have to act on. Okay? Is it just a single table that's damaged? In which case you can run repair, and if you've got, you can run check table with repair, and if you have the table isolated in a file group, you could restore just that file group. Unfortunately, there isn't table level restore even in SQL 2008. That is an option that the SQL team is looking at for Katmai +1 or Katmai +2. Okay? That is going to come. Can you restore a single page? Is it just one page that's damaged? In which case you could do a single page restore. On Enterprise Edition, you could even do an online single page restore. So there's a whole bunch of different questions, and if when you get down to the bottom of the list of questions, you still have a choice, repair or restore, then basically choose the one that's going to take the least amount of data loss or downtime, whatever your SLAs dictate. Okay? The point here, though, is that when the disaster happens, you don't immediately have to jump at one solution all the time. Take the time to assess what the damage is, figure out what the best option is, and then go with that option. Okay? Don't immediately jump and do the panic option. So the very best way to avoid data loss and downtime is to use backups in various granularities. And there's an enormous number of different options. Kimberly could talk probably for days about backup and restore. It's one of our favorite subjects. A full database backup is the best way to start. At least gives you one point in time to restore to. If you have a series of log backups, that gives you an infinity of different points in time you can restore to. Okay? Remember that a disaster is not just limited to corruption. It could be somebody dropping a table, for instance. In which case, you'd like to be able to go back to the point in time just before the table was dropped to get as much data back as possible. That's only possible if you have log backups as well as a full backup. Okay?
And actually, we'll talk about the restore with standby and stop at in our demo session on disaster recovery on Thursday at lunchtime.
Yeah, Thursday lunchtime, we're doing a demo session for 45 minutes on disaster recovery techniques where we'll illustrate a bunch of these different things. So if you want to see some of this stuff in action, come along then.
Well, we'll show a little bit, because I'm your demo monkey. That's why I'm here.
Yep. You have to have backups to be able to use them. Okay? This seems kind of obvious, but from the number of different questions I see on forums and for product support, people getting themselves into trouble, and someone will post it on the forum and say, I have all these corruptions, what do I do? And someone will post back, well, restore from your backups. Then there'll be a few hours delay, okay? And then there'll be this, I don't have any backups. Now what do I do? And then hopefully somebody, people will post back saying, you idiot, but hopefully somebody will post back. I usually do this. I'll post back and say, okay, now let's have a look at what the corruptions are and what your options are now that you don't have backups. And you're usually looking at somebody running repair and taking data loss, okay? So you've got to take backups. And they've got to be valid, okay? They can't be corrupt. So don't just take a backup, stick it in a vault and forget about it until a disaster actually happens. Take a backup and then restore it and make sure it restores. We like to say you don't actually have a backup until you've restored it. Okay?
Another quick example I see a lot of is developers who insist that their server is not critical enough to get into, the regular and automated backup processes until, of course, something goes horribly wrong, and then they come to you and you say, well, restore from your backup, and of course they say, we don't have one. Database maintenance plan wizard, it's not my favorite of features just because I have some issues with the combination of features you can set up. But as far as database backups, if you guys create a database backup, database maintenance plan that is based on all databases on the server, even if the developers add new databases, it actually picks those up in the database maintenance plan. So it's actually not a bad idea to consider on the servers where they want to be unmanaged per se, just even full database backups that occur, daily or weekly, depending on database size. So.
Okay. So what if the backup is corrupt? Now I said about the continue after error option. Okay, so you can force the backup to be restored. Be careful though if you use that, because you're restoring a corrupt backup, which means you're restoring corruption into the database. Now, it could be that the database only has a small amount of corruption in, but the backup has an awful lot of corruption in. So by restoring with continue after error, you're actually making the database more corrupt than it would have been if you'd just run a repair. Okay, so be careful. In that case, you want to restore the database to a different location, and then just run a CheckDB on it and see how corrupt the restored corrupt backup is. Okay. But again, if you have no database at all, then you've got no choice. Question, yeah.
If we do a backup with continue after error, and then do a restore to a separate system, for instance, would a backup on that second system be a consistent backup with maybe a one will fall back again or not?
So the question is, if you have a corrupt database and you take a backup of it with continue after error and restore it on a second system, is that database then a consistent database? And the answer is no. It'll be an exact physical copy of the corrupt database originally. Okay. So the act of taking the backup, even with continue after error, doesn't perform any repairs. It just sucks out the corrupt database and puts it in a backup. When you restore that, it's still going to be corrupt. Okay. Okay, the question is, will it be an exact copy, or will there be more corruption because the linkages are screwed up, for instance, so it wouldn't know what to back up? The answer is it's an exact copy. A backup does not do any interpretation of the pages. It just sucks them straight off disk, extent after extent after extent. It doesn't process anything at all. Okay, so it's an exact copy. So, what if you don't have a backup? Well, it depends. Okay, depends what's damaged. If it's a data file that's damaged, then you're going to be able to run repair. If it's a log file that's damaged, then it gets a lot more complicated. You're going to be able to run a repair of sorts, but the fact that the log file is damaged means that not only is the database corrupt, but recovery hasn't run on the database, so there's even more inconsistencies in the database on top of that. Okay? So if you get to this point, before you do anything at all, take a backup. Okay? Because one of these repair options could have a drastic effect on what's stored in the database, because repairs delete stuff. Okay? Repair exists to get the database structurally consistent. What does that mean? It means that repair is there to get the database into a state where CheckDB, the server can run on it without AVing or falling over or causing more problems. Repair does not exist to save your data. Now, that doesn't mean that repair goes out of its way to delete data. It means it doesn't go out of its way to try and save every last bit and byte of your data. Okay? It's trying to do fast, efficient, correct repairs. All right? It doesn't save any of the data that it deletes. Most repairs delete stuff. That's the fastest way to fix things up. Delete something and fix up all the links. Okay? So don't think that if you've got a corrupt database and you run repair, all your data is still going to be there. It's not. Okay? As I said, it can't fix anything. It can't fix everything. I gave you some examples of the things that it couldn't fix. System table corruption, PFS corruption, there's a few other things. I did a blog post about a week ago with a list of all the things that CheckDB can't fix. Okay? And repairs are always offline. People ask, why can't repairs be online? It's hard enough getting repairs to work offline, okay? Then adding in locking and having to make sure people aren't changing things underneath you. Offline is always going to be the case for repairs. Remember that repair is a kind of last resort after not having any backups. So the best thing we can do is to get it run efficient, correct, and fast. Okay? Not trying to be smart about having it online and so on. It's always going to be offline. So just to nail the point home, repair allow data loss was very aptly named. Okay? It means it's going to lose data. It's going to have to do something that's going to cause data loss to run that repair. Okay? And it's a Band-Aid. It's not a Band-Aid, that's duct tape, but it's just holding things together. Right? You really want to have a backup rather than having to run repair. The reason for this is, so the database structures get fixed, but what about your foreign key constraints? What about any inherent business logic you've got in your database? CheckDB doesn't care about that stuff. It's just making the database structurally consistent. So once you've run repair, you don't know what state your data's in, because it's going to have deleted a bunch of stuff. Okay? And there's a blog post that I did there that called Last Resorts That People Try First that explains a lot more about repair and why repair is bad. So that's the easy case when it's just a data file that's damaged, because there is a tool that can repair most of the things that are wrong. But what if the log is damaged? Okay? As I said, if the log is damaged, that means recovery hasn't run. So not only is the database possibly structurally consistent, your data is also transactionally inconsistent, okay? So if there was a transaction happening when a checkpoint was taken, then you've got some kind of changed pages on disk, but the rest of the database isn't up to date with that transaction because recovery didn't run. So if the log is damaged, what can you do? Kimberly.
That would be me. Okay, so what I've done, and we will provide all of the scripts that we're demoing so that you can kind of go back and play with this if you want. And in fact, since there are a few of you that are on SQL 2000, I'll also provide a version of this script that works for SQL 2000, although it's a little bit different of a process. You have to hack a system table in master. So that doesn't sound good, right? And as a result, I created a stored procedure that kind of protects you from potentially hacking too many objects in master. So I've got a couple of bits of code that I'll make sure that I supply for 2000, in addition to this one for 2005. What I've done for 2005 is I've basically generated a backup of my AdventureWorks database and then restored AdventureWorks as a copy so that you weren't messing with your original AdventureWorks database. I know it's very critical to all of you, but I just figured I wouldn't mess with that one directly. I also checked the recovery model of AdventureWorks, and based on the default behavior, I then set it to the full recovery model. I could have done this as an if, but just a quick check on that. Then after it's done, just like any other database, as you make changes to a database, as you change the file groups, the partitioning, whatever, you always want to do a backup. So imagine that that was kind of my first backup that I really had. And we kind of think of what is the data like after changes have occurred and so forth. So I'm going to go into AdventureWorks and just select a quick set of data so that you can see a little bit of it. So I'm going to start making some changes to some of these rows here just to get a little bit of insight. And in this first transaction, I'm going to change the last name to a not very likely value, but I'm going to change the last name to be committed for a transaction that is an implicit transaction. It's just going to commit, so nothing overly exciting. I have it echoing the input, by the way. That's not a default behavior. That's something I changed in Management Studio. But there you go. You can see the one row was affected. And going back and looking at the data, nothing exciting, but there's my committed row, right? So in this next transaction, I'm going to do something that we never recommend, and that's I'm going to span batches between the begin and the commit. So in this case, I'm going to begin the transaction. I'm going to set contact ID 3 equal to uncommitted, and I've done the modification, but notice I did not yet commit. So at this point, looking at the data, since I own the locks, I can obviously see this row has a value, and just to reiterate the point, I have not yet committed that. So a good question that people ask is, you know, what's the database look like if there is no log and you have some type of disaster? So I'm going to simulate a disaster, but we kind of know what's going on here, but in the real world, you could imagine thousands of transactions all simultaneously running at the time of a disaster, and you could get some interesting scenarios. Well, I'm also going to simulate a checkpoint very quickly. Now, a checkpoint writes all changes that are currently in memory to disk, regardless of whether or not they've committed. It's a common misconception that people think checkpoints only write committed data. That's not the purpose of the checkpoint. The purpose of the checkpoint is to synchronize what's in memory to disk so that if there is a disaster, the amount of recovery time will be reduced because they'll be closer to current. So now I'm going to simulate a disaster by doing a shutdown with no wait. Shutdown with no wait cannot be inside of a transaction, so I'm going to put it in another window. Now, this is not something I am recommending running. This is literally like pulling the rug out from under SQL Server, and SQL Server is now no longer running. So the way that I'm going to simulate my disaster is I'm going to go out, and you can see these are all in comments, so if you wanted to repro this. But with SQL Server shut down, I'm going to change, and I'm going to go, and in this particular case, I'm going to mess with, okay, my data file, okay, and if I go and, yeah, actually, I take that back. I'm going to delete the log. I thought so. I thought we were talking about the log, and I have my little delete the data file in the notes. I will fix the comment. But I'm actually going to delete the log file, and that's what Paul was saying when we started.
And just to make it clear, this is also something we don't recommend.
Yeah. Yeah. This is definitely not a good idea.
It's great for a demo.
The server shut down. right? I'm now deleting the log file, and without the log, SQL Server is not going to be able to do recovery, and that's the point. If the log is damaged, what happens? And what do we have access to? So I delete the log, and I will just restart SQL Server from here since I can. SQL Dev 01 is my instance that I'm running, and I'll get back in here, and first thing I'm going to do when I get back in and the server's restarted, let's look, it's restarted. I'll do a helpdb and I get this lovely helpful transport error, which is really annoying, but I'll just rerun this again because after you get that transport error the first time, it does connect and rerun. So you'll see that AdventureWorks copy is not in my list. A database that has not recovered is not going to be listed, but you can see that AdventureWorks copy is there, it's just in a recovery pending state. So the question is, can we actually get in? And you just saw that it's not even listed. No, we can't get in, it's inaccessible, insufficient files, and so forth. See the error log, and if we go and look at the error log, all it's going to really tell us is they couldn't find the log file because the log file was damaged. And the whole point, you know, you cannot bring this database online. You've got no access to this database whatsoever, and to be honest, that's for good reason. SQL Server's response to a database that is damaged, and especially when the log is damaged, is you need to restore from backup. But again, what if these developers come to you and say, I don't have a backup? Well, then this would be really an emergency. So even if you try to back up the log, you can't. You cannot get in, right? The log files are inaccessible. The backup log will fail. So the question is, what do we do? And the answer is, you know, it really is a bummer, okay? If you have any backup whatsoever, to be honest, you're probably better off restoring that because you're guaranteed a transactionally consistent point in time to which you can recover. But if you don't even have that, you could set your database to emergency mode, okay, which is what I just did here. It was different in 2000. You had to hack a status flag for sys databases, but here in 2005, it is documented as emergency mode. I'm going to go into this database, and just to prove the point, even though you can get in, right, you're going to get data that's in a transactionally inconsistent state, and it's not even as pretty as I just did here, to be honest. I mean, we knew what was going on. You could have index rows that don't reference the right data rows. You could have foreign keys that don't reference the right key values. I mean, you could have horribly inconsistent data. This is relatively easy. We knew what was going on. But in the real world, in a large database, are you going to really sit down and manually verify every row, every reference, everywhere? So just to make one more point, this database that's now in emergency mode, if you try to modify anything, you'll actually also have a secondary problem, and that's that since you've bypassed recovery mode, this database is in an unusable, at least transactionally, state until something coming up.
Okay, thank you.
You're welcome.
Unusually polite of you. Just to reiterate, so emergency mode, it is now documented in 2005, okay? It existed in previous versions, but it was undocumented. As Kimberly said, you had to hack the system tables to get in there in previous versions. So you can get in, you can access the transactionally inconsistent data, but that's the key, it's transactionally inconsistent. So the data's not guaranteed to be accurate, okay? But if the log is damaged and you don't have a backup, it's your only choice. So in previous versions, what people might do when in emergency mode, and this little thing here is just saying, you know, if you do this, you're basically gambling with your data. There was an undocumented command in SQL Server 2000 called dbcc rebuild log. It's pretty well known. And what that would do is what Kimberly just demonstrated. It rips out the transaction log, plus any transactions that are in there. It just rips it out and builds a new one, okay? So if you run this dbcc rebuild log, then you're probably causing more problems than there were in the first place, okay? And again, there's a blog post on there that gives you all the nasty information on that. Now, in SQL Server 2005, we came up with this thing called emergency mode repair, which does include rebuilding the transaction log. And you might say, well, why on earth did we do that? People do get themselves into these kind of situations, okay?
Not you guys,
yeah,
other
not
people.
you guys, right? And we in the SQL team, when I was back there, we would rather that there was a documented, workable approach to fixing this than having to use an undocumented command with information taken off the internet about how to use it and so on and so on. So we came up with this thing called emergency mode repair. So if your log is damaged, you can put yourself into emergency mode and run this emergency mode repair, which is running checkdb with repair allow data loss in emergency mode. And here's what it does. First thing it does is it does a kind of log analysis. The idea is we're going to go and rebuild the transaction log, and the database is corrupt anyway, so why not force recovery to run and get as much information from recovery as we can from the transaction log. So basically what this is doing is recovery with continue after error. Okay? So you can't do this in any way but apart from in emergency mode repair, but it sucks as much information out of the transaction log as it can. And then it rebuilds it. Okay? And then it runs repair. So it's rebuilding, which is going to cause more problems, and it's running repair, which is going to hopefully fix them all. Okay? And if everything works, you're up and running. Okay? So again, there's a blog post about exactly how all this stuff works. Now, I get asked, what if it doesn't work? That's the only answer I have. URLT, which is?
Update resume, leave town.
Right. I've never seen this not work in production, because this is the very, very last resort. There's nothing else after this, okay, if it doesn't work. I can think of a pathological case where, say, the file system is damaged in some way, where it might delete the transaction log and it can't create another one. But if your file system's damaged, then you've got a lot more problems anyway. So again, I've never seen this work. I've seen people use this. I've never seen it not work, okay? So, but remember, this is the very, very last resort. This is not something that you do when you hit the panic button when a disaster happens. You don't immediately go and do this, because it's really damaging, okay? Remember, it's going to go and trash the transaction log, then run repair, okay? It's always better to have a backup. But if you don't have a backup, there is a solution for you, which is this. And Kimberly's going to show you.
Okay, so that same database that we just went into emergency mode repair, remember that if you try to make a modification, if you try to do anything in this database, you can't, because there's no log. So what you need is, like Paul said, to rebuild the log, but in doing that, you will put yourself into a point in time where SQL Server knows that your database was transactionally inconsistent. So just to be very clear on this, PSS will know. If you ever call in with corruptions, they can look at a database and see that the database's log has been rebuilt, and at that point all bets are off, because you have very likely created those corruptions. So just be very, very aware of this. This is not something that you want to do, but again, you're in an emergency mode situation, so you think, okay, I'll use this checkdb repair allow data loss, and even this won't work directly because you're already in emergency mode, and they know you're in emergency mode, and they're kind of wanting you to take it one step further and say, no, I know that I'm in emergency mode. I really want to repair and allow data loss to get that database back up and running. So by setting single user mode and then doing checkdb repair allow data loss, this is the magic combination that they put together to actually go through, and we've got to give it a little bit of time here to go and rebuild the log.
I hope it works.
Okay. He hopes it works. Sorry. There. Okay. So it always, by the way, squawks when you first start, and then it actually does rebuild the log, because this is a little bit scary. I remember the first time I saw this and I was like, wait a minute, it didn't work. It does. And you may actually want to not say with no info messages. You might want to get the details back, but it does first fail the checkdb, and it basically says, hey, we can't access the log. And then I even think this is a little bit awkward. It says the log file cannot be rebuilt, blah, 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 but then you get the log has been rebuilt. And this is kind of the weird combination because of the way checkdb runs, right? It checks for the log, it squawks about the log, but then because you are in single user mode, in emergency mode, after it gets through some of the default checks, the last thing it does here is it says, okay, I'm willing to rebuild the log. Now that the log has been rebuilt, you can first of all see that we still have our damaged data. I mean, it's not fixing that because it doesn't know. Only the log knew the state of this data. You don't have a log. So you are going with transactionally inconsistent data. However, you can now start modifying data, and you know, you're golden. So okay. I do have an extra thing if you wanted to play with this. If you had saved a copy and had attached it, if it weren't damaged, would that have worked? And the answer is yes. And that's another option in it. If you guys, before you play with this exercise, before you delete the file, you can save the files and then reattach them. And you'll actually say they reattach fine when you have both of them. It's only when you don't have a log that they can't do anything with it.
Thanks. Okay, so that's recovering from corruption. So for the last 5-10 minutes, oh, quick question. Yep.
Now you have a database that's not transactional, it's consistent, and that will continue to be messed up.
That's correct.
Is there any way of trying to get to a state where you have a better life?
A cabin in the woods, no electricity.
Absolutely. The question, yeah. Oh, yeah. Right. Yeah. Question is, you know, if you get to this situation, then you've got a messed up database. Is there any way to get out of this? And the answer is no. There's no way, unless you can go and manually verify all the information. You can't tell what's been messed up by this.
Go ahead.
You really have to have a backup. That's the best answer. Is, you know, if you get yourself into this situation, this is the ramifications of having to run emergency mode repair. It is a last-ditch resort.
Yeah, I would agree. There is one thing that you could do to a certain extent to get yourself a little bit better, but not perfect, and that's rerun verification of all your business rules. Which means if you have check constraints, revalidate the data, because you could have data in a state that's not valid. You could have foreign keys that aren't valid. So you could at least re-verify all your business rules. But to be honest, that doesn't tell you what the data value was. It doesn't tell you how you should change it. And something like my modification that just hadn't committed, you know, there's nothing there because I wasn't violating any business rules. So, you know, the real answer is no. But you could at least do a few checks that are business rules.
Yeah. Pardon? Questions, are there timestamps on each page? The answer is no. There's no timestamp. Okay. So I want to stop questions there because we've got about 5 minutes left. We're going to run a couple of minutes over, but I want to get through this last section with you, okay?
Actually, there's not much to go.
We'll hang around we'll hang around outside as well for questions, so we're happy to do that. So that was recovering from corruption. So a few best practices, and then the last couple of minutes is these examples I want to show you. So first thing, and there's blog posts on all of these things, service level agreements, okay? 5 questions that I think every DBA should be able to answer yes to, right? Do you know what SLAs are? They're service level agreements, okay? They're important because they're a contract between you and your employer or you and your customers that you're going to provide this level of service. Do you know what your particular SLAs are? I've talked to DBAs that say, yeah, I'm responsible for the SLAs in this database. I don't know what they are though, but yeah, I'm responsible for them. You know? Do you think you can meet them? Okay, you know what your SLAs are. Have you gone to the trouble of designing a system that's going to allow you to meet those SLAs? Okay, and then if you think you can meet them, do you know for sure that you can meet them? Have you actually tested your system to meet these SLAs? Okay, there's a DBA that I knew that had a 300 gigabyte database, and he was relying on full backups as his recovery mechanism. He had a downtime SLA of 15 minutes. Okay, I don't know of any system that can restore a 300 gig database in 15 minutes. Okay, so that wasn't going to work for him. So again, the answer to all these has to be yes, right? How often should I run CheckDB? It all depends. My favorite answer, it depends, okay? Depends on a bunch of different things. The 2 most important things are stability of your I/O subsystem and your backup strategy. A couple of examples. If you know you have a flaky I/O subsystem that's causing corruptions and you're not taking any backups, then your only option is to run repair, okay? So as soon as a corruption happens, you're going to have to run repair, which means you're going to take data loss. In which case, you should be running CheckDB probably in a tight loop, because as soon as that corruption happens, you want to run repair to limit the amount of data that you're going to lose by running repair. At the other extreme, okay, you may have a really rock solid I/O subsystem, okay, with a really, really comprehensive backup strategy. You've probably got a bit more peace of mind than the flaky I/O subsystem with no backups, so you can probably get away with not running CheckDB quite so often. Okay. I get asked this a lot, how long is CheckDB going to take to run? On this slide, I'm going to limit myself to say, look at all those things it depends on, okay? That's different for absolutely everybody, so I can't answer that, okay? The best thing I can say is run it once, and then you'll know reasonably well how long it takes and how long it's going to take when you have a disaster, okay? So that if it starts to run a lot longer, you know that you've probably got some kind of corruption. There's a blog post there that goes into a lot more detail about all these different factors and how they affect the runtime of CheckDB. How can I consistency check a VLDB? So I said at the start that sometimes people try running a consistency check and they find that they can't for whatever reason. A number of different options you can use. First one is don't run any checks at all. I don't recommend that one. Second one is run with physical only. It runs an awful lot faster. Doesn't take up so much resources. Third one is break up the checks. You could manually partition all the tables in your database and run check tables on a small subset, say every night for 7 days. You run a seventh of all the tables through check table, and then you run the equivalent of a CheckDB. You could use partitioning. You could run, let's say you have a sales database with a single read-write partition and all your previous month's data in read-only partitions. You've probably got good backups of the read-only partitions. It's not so critical data. You could do a DBCC check file group of each of those partitions, say once a week, and a DBCC check file group of your read-write partition every day. Okay? Or you could use another system. You'll take backups, right? So you've got to restore them somewhere to test that they're okay. So restore them on another system and run a CheckDB on that database. The vast majority of the time, that database is going to be fine, which means that when the backup was taken of your production database, it was fine too. Only drawback of that is if you come up with a corruption on your secondary system, you don't know whether it's that database or your backup or the production system that's corrupt. But hopefully that's a very small minority of cases. Okay? Bottom line, don't give up. Okay? There's always an option to be able to run consistency checks. Just to give it a little bit of thought. If you're having problems, shoot me an email and I'll help you. I've helped lots of customers do any one of these different things. Okay? When you do recover from a corruption, don't just carry on running. Always do a little bit of root cause analysis to figure out what happened. Something caused that corruption, always, okay? The odds are it's going to happen again. Next time you might not be quite so lucky, okay? So you can look in the error log, you can look in the event logs, you can run diagnostics, run SQL IO-Sim that I told you about, okay? And you can turn on page checksums, okay?
So we're really at the very last couple of slides just to go through a couple of examples
These
so
are
you
the
can
fun
see
ones.
this is the funny
Four
part,
more
so
slides.
Just four more slides.
Okay, so I was involved in every one of these different cases. Okay, I will not tell you who they were. Okay, and these are increasing magnitude of loss. These are the worst
He
four
hasn't even
cases I've
told
ever
me.
seen. Yeah. Okay, so each one of these slides has got story, cause, resolution, and lesson learned. First one, database is corrupt. This happened while I was actually in PSS doing an internship back in April 2004. Oh, the 2006 should say 2004 there. So, small bank in the US. Okay, their database went down. It took them 3 days to get it back online. They had a full backup from January, and they had half-hourly log backups until April, and then their database went down. To their credit, they restored the full backup, and they restored every one of those half-hourly log backups, and it worked. I should say to SQL Service credit, really. It worked. They came back online, but it took them 3 days. Okay. At the same time, they ran a repair allow data loss on a backup of their corrupt database, just in case the restores didn't work. And the repair deleted a whole bunch of stuff, but the restores all worked. But they were down for 3 days, okay? Lesson, plan a backup strategy that allows an efficient restore. That wasn't very efficient. Number 2, database lost with corrupt backup. This was a very large investment firm in the US, and the database was storing all 401k, that's retirement fund information for their customers, okay? The database got backed up. They were moving to different hardware. The database got backed up. Before the database was restored, the technician flattened the old hardware. They went to restore the backup and found out that it was corrupt. Okay? So they'd lost the database and they had a corrupt backup. This was on 2000, so there was no continue after error. In this case, what happened was the SQL team actually put in a special build, continue after error for this customer to force that database to be restored. Okay? It was that big a customer. So they managed to get the database restored, and they managed to do a bunch of manual analysis and fix up the data. A bunch of people lost their jobs for this one, okay? And not just the DBAs and technicians, it went up the management chain. A bunch of people lost their jobs, okay? Lesson learned, always validate your backups, and don't delete that database until you've actually restored it to a different place and you know it's valid.
I'd even argue don't even delete your history of your backups until you know that you've got sequences that work.
Yeah, okay, last 2 slides. Database went down for 3 days. The database was unfortunately storing online stock trades for a large investment bank's customers in the UK. Okay? They found that they had a corruption. This actually involved product support. The product support guys did the wrong thing here, and I was involved with this. This took 6 months or so to the fallout from this. They started a CheckDB, but it started to go long, so they killed it. They didn't know how long it usually took, but they just thought, well, it's kind of going a bit long, so I'm just going to kill it. Okay? Then they started to restore from the backups and didn't have a very efficient backup strategy, and they came across a corrupt backup. Okay? So then they had to restart CheckDB to figure out what was wrong, to figure out what they're going to have to do. So they killed the first CheckDB. I think it was after about 10 hours or so. And then they took about half a day starting to restore their backups before they came across corruptions. Then they had to let CheckDB complete. And this was the one that took 37 hours. When it completed, they found that it was a single page and a non-clustered index. Okay. The fallout from this was that the customer was actually fined by the UK government for their stock trading system being down, because this was online stock trades, and that's against law in the UK apparently. Okay. So
Only $10 million though.
only $10 million. This is not the worst case. Okay. Lessons learned. Know how long CheckDB takes to run. Validate your backups. Okay. Last slide. DB8 comes to work to find the database is completely gone. The database stores all the tax records for a large US state. Okay? Gone, vaporized, no backups. Okay? The third-party technician that was doing something had accidentally formatted the drive that the database and the backups were stored on.
Same drive.
Same drive. Okay?
Central.
It took 200 staff members 3 weeks to re-enter as much data as they could. But they didn't get everything, okay? They lost a whole bunch of data. The estimated losses to that state in the US are over $2 billion. Okay? Nobody lost their jobs, okay? Amazingly. Okay? Lessons learned, multiple backups, don't store them on the same drive as the database, and don't let technicians have access to this kind of stuff, okay? There's no way that guy should have been able to format that drive, okay? So, takeaways. Don't wait for corruption to happen. Be proactive, okay? Figure out what's going on. Early detection is going to minimize data loss. It's going to minimize downtime. Understand the tools you've got for recovery, okay? Don't wait until your disaster happens to try and figure out the syntax for restore, okay? Work out a disaster recovery plan that allows you to meet your SLAs and cope with a bunch of different eventualities. And when the disaster actually happens, dive your plan, okay? And the last thing, practice, practice, practice. Make sure that if a disaster actually happens, you're able to use the tools.
Yeah,
Okay.
and we'll post these scripts, but there's also corrupted databases that are posted on Paul's blog that you can play with. And actually, Tony Rogerson, we'll put a link to Tony's site.
Yep.
He actually has a great way of helping you corrupt databases if you want. So
Yep.
yeah.
Oh yeah, for testing,
In your
right?
spare
Yeah.
time, right?
So thank you. Please don't forget to fill in an evaluation on ComNet so we can improve the sessions and so on. And we'll stick around for questions. Thank you very much for listening.
Thanks.